All right, here's the part that we're going to make. These scallops are the topic of this particular video. There are 6 of them, equally spaced, 60 degrees apart, 360 degrees around, on a 1/4 inch diameter piece of material, approximately 6 millimeters. Pretty small stuff. It's about that big when it's done. There are several different ways to do this, and the first way I'm going to do it, I'm going to call technique number 1, and it's probably going to be the technique that the majority of you will elect to use. If you don't have a ball mill, if you don't have an indexer, this is probably the go-to technique. Let's take this and look at it for a second. Okay, 6 scallops, 60 degrees apart. Boom, that translates to a hexagon, right? 6 sides. If you take them 60-degree increments and connect them, you have a hexagon. What do we know about a hexagon? All 60-degree increments, not a whole lot else. I am going to position my part so that one of the true radius, one of the true center lines is diameter, is true to one of the axes on the machine. So let's call this the x-axis of the machine. Now let's call this the x-axis of the machine because it just looks better. With the 250 diameter part, we know that from the center to the edge, the radius is 125. Great. Now, unless you're doing this on a rotary table, which we're not going to do it on a rotary table, it's being done in a vise using a V-block. How do we find the other points? There's only 2 numbers that you need to remember. 0.5 and 0.86603. So what? What does that mean? Well, let's take a look at the triangles that we need. We need to find it from the center line. We need to find it from the x-axis up, right? So here's one line. So there's the triangle that you need right there. You know this leg of your triangle is the radius because it's the same thing. So 125 on the radius. What else do you know? We know that's 60 degrees, right? It's getting easier. If this is 60, that's got to be 30. Because the total of all the angles in a right triangle equals 180. So with this being 90, 90, 60, and 30, 180. So great. Still don't have any numbers for you, but it does get easier because in a 30, 60, 90 triangle, see that? How fast that was? That was not camera magic. That was real time. 30, 60, 90 triangle, the radius of the bolt circle is always twice as long as the short side. Twice as long. That's the easiest thing in the world to remember. The radius of the bolt circle is twice as long as the short leg of the 30, 60, 90 triangle. So if you take the radius, which is 125, multiply it times 0.5, effectively splitting it in half, one leg is 062.5. That would be this leg. And back again. Now the bottom leg is the radius times 0.86603. This is sines and cosines of 30 degrees, yada yada. But it's just easier to remember the 0.5 and the 86603. Who cares what they are? Because they work. Radius times the 0.86603, 1082. 108 thousandths and 2 tenths. Okay, we found that hole. What about all the other holes? Well, hey, Mr. Wizard, check this out. When you connect all of this hoo-ha, do the same thing over here. Bingo. You've got 4 identical triangles, which means you've got all the numbers you need because it's 062 here, 108 up, 108 down, 062 off. This is it. One triangle, you've got this whole thing figured out because you know the radius to start. Now when you do this technique, drilling to do these scallops, you're going to need a little bit bigger material than the diameter of the part, because when you try to drill half a hole, well, chances are that drill's going to hit that edge of that material and go whap, walk right off or explode. So whatever size scallop you decide that you're going to use, add that diameter to the diameter of the material, and that is the raw stock that you need to start with. All right, simple. And turn up a bunch of holes. It's going to look like a gun cylinder on a 6-shooter. Then we're going to turn away the OD, and we're going to end up with 6 half holes. Easy peasy. Let's do it. I'm going to create my part a little differently than is called out on the print. I'm going with a brass knob, and I'm going to use it as a cap that I'm going to press onto a commercially available stainless steel cap screw. So instead of having to single point that or run an 080 die or 172 die down over top of that, using that screw option gives me a stronger thread and a more complete thread. There'll be no run out from like a die would leave you. It's a great option, and it's going to work well. I'll face off the two surfaces when it's done so that there's a seamless transition. Naturally, as with any machine setup, the first thing you're going to have to do is indicate the part to find the dead center of the material that you are using. Set your dial, set your digital readout to 00 at this point, and then we're going to start drilling. The first 2 holes that I'm going to drill will be the radius of the bolt pattern. I am going to go with a little bit bigger diameter than the 062 calculated. I'm going to use a 070, okay? So I'm going to go 125 off center each way for the first 2 holes. For the remaining 4 holes, each hole is going to have a constant dimension from the hole prior. So when I dial in this bottom corner hole, I'm not going to go over here and do it or down here and do it. I am going to come directly across. Since the y-axis is already going to be set, each hole I'm only going to have to change 1 number. This offset is the 1082 shown on the diagram. I'm going to go with 1085, close enough. And 062 and a half, closer to center. Now when you use this technique, please be aware that the finish inside these holes is going to be a very visible feature on the finish knob. So if you want to ream them or go very slow and use oil, that is entirely up to you. Okay, real time, center drilled and drilled 6 minutes. 6 minutes and 32 seconds to be exact. Let's take it over to the lathe, turn this down to a 1/4 inch, and watch that scallop pattern of the knob fall right out of there. First operation is to create the bore that will accept the head of the 172 cap screw. And it helps if you tighten down the tailstock so you don't get any jump in your center drill. Going to go about 10 thousandths deeper with the drill than the size of the cap screw head thickness. So I do have the option to run the head of the screw all the way to the bottom of this and face it off so that they are both flush. Next operation in line is the small lead outside where the cap screw will sit. Small diameter. Draw, face it off, and turn down the 250 diameter on the print. Now because I'm broaching this and I don't want to dead end the broach into a solid object, I'm going to put an undercut in so that all the chips and the tool fall free. Small 45-degree chamfer on either side of all the scallops. File in the radius. And hurry up, get it back in there with some memory. Forward, up, and reverse. By deburring it forward and reverse, you can get the leading and trailing edges of the knob, and you can round them off to your satisfaction. Let's say we modify a cap screw, push this cap screw in there and part this thing off. Let's do it. Occasionally when you film components this small, the camera angle is very difficult because the camera angle, the best camera angle, is the line of sight. And that makes it pretty hard to see what you're doing when there's a camera in your face. That is a 172 cap screw that's been threaded into a piece of sacrificial brass, and that's being used as an arbor. It's not only going to be used as a turning arbor, but it's going to be used as a pressing arbor too. So when I've matched the head size that I'm looking for to the bore size that was created in the knob, I will not take that out of there. I will unloosen it because I know the future operation dictates that, so that's what you're seeing there. And it's always nice if you use a piece long enough that you can actually grab with your bare hands. I have a set of needle nose pliers that I broke off and turned into pin pullers, and they work really well. I'm going to put the knob back in now. And that little piece of brass is going in a drill chuck in the tailstock. So unfortunately, it's obstructed by the camera angle right here, but that cap screw is in that drill chuck. It's shown clearer later on in this video when I do part number 2. I'll repeat this operation. Loosen the drill chuck, unscrew the sacrificial brass, and now you're ready to part this thing off. You can see the concentricity is pretty good. I'm going to face off the shoulder where the cap screw is so that the brass and the stainless are seamless. Gently deburr that leading edge, come in from behind this part now with the parting tool. Open it up so I have a little bit better visibility from my angle. Using a jeweler's loupe, I can look for tool contact, and voila. Remove the knob, rub it on a couple of sheets of emery. Let's see what we come up with. Final result is favorable. 2-piece assembly, nice press fit, stainless steel threads. Now the finish inside the scallop is going to be determined by the finish inside the hole, or how much effort you put into it after the fact. File it, use emery, whatever floats your boat. But that is certainly one option for you, and you are going to need bigger material if you decide to drill it. You could plunge it with an end mill, of course. You could peck away at the 6 locations with an end mill coming down. That is certainly one option. You could hold the material in a spin indexer and do it with a ball end mill. That is another option. You could do it in a vertical setup with a hex collet block and plunge it or drill it. That is another option. But an option that you probably won't think of is to do this entirely on the lathe. Come off finished looking like this right off the lathe. And that will be the next thing that I demonstrate. Something that I showed a while back while doing the shaper. We're going to do it again, and we're going to form these 6 little serrations right there. All right, so nothing left to do but to do it, right? Let's go. The indexer that I'm going to use to do the broaching operation that I'm about to show is strictly a piece of paper that I've stuck to my nose of my machine, 60-degree incremental marks. I actually drew that up in CAD and printed it out, so they're pretty accurate. And the pointer is a piece of welding wire held to the machine with a magnet. By manually rotating the machine. I'll actually be doing this from behind the machine, but I can't do that right now because of the tripod's in my way. I will just spin it until the line's in line with the wire. So there you go. We'll just do that 6 times, broach it 6 times, hopefully come out with something good to look at. But that's and unless you have a mechanical indexer on your machine, I figure this is the next best thing. Simple, effective. Let's do it. Prior to the broaching operation, I thought a little closer look at the tool would be a good idea. I have a positive top rake, a positive trailing edge rake or bottom rake, back rake. Let's see if I can get this in focus. That is a nothing fancy tool. I believe that is about a 15-degree wedge, maybe 10-degree wedge, with a hand ground radius on the front, spaced up so it'll be on center with the lathe when the broaching operation comes along. That's it. Nothing fancy. Grind to suit. Once the tool is in position and you're ready to go, the finish that you'll achieve by broaching this scallop into this little handle is far superior than the drill finish, and I think that'll be apparent here in a second. This is a very difficult camera angle, and it's a very difficult thing to see because of all the lights and such, so I will do my best not to mess this up. Hang in there and check this out. This is really nice. This part will come off of here complete. It does not have to leave the lathe. It'll be done when it comes off. All right, we have a witness mark. I want to go about 30 deep, 35 deep, so I'm going to add 70 to whatever reading I have on my dial. Puts me at about a 130 on the dial. I will finish each one as I go. Here we go. Each pass is about 3 thousandths deep. Make sure the tool is nice and sharp so you don't have too much deburring to do. It is always a little bit more difficult to deburr over interruptions than anything else, but that can work in your favor for this particular part because you're going to want to round the upper corners of this scallop off after the fact. Simple 60-degree visual index in between movements. And one of the things I like about my lathe is I can reposition my hand wheel on my carriage to any clocking position that I want for convenience, and that really does make it easy to oscillate the carriage back and forth like this. Nice sharp tool, take your time, and you should be happy with what you get. The finish on the inside of the scallop is absolutely beautiful. It is a linear finish. There are no marks. It's going to be as clean as the tool and as fine as the depth of cut on the final. Little blowout on the back side. You can see the burrs. I think you can see the burrs. They are really small. Well, let's press the threaded section into this. I'll try to maintain this camera angle so you can see how that's done. And we'll part this one off and compare it. The method that I use to turn down the heads on these little cap screws is quite simple. Piece of brass threaded to match. Run the screw all the way in, torque it down, put this in a collet, cut the head of the screw. Now leave the screw in this little piece of brass after the fact. Pull it out of the collet, put it in a drill chuck in the tailstock, and use the arbor that you use to turn the head as the device to hold it to press it in. And then once it's stuck, unloosen the piece of brass, back it off, and you're ready to part the knob off the parent material. The turning arbor is now in the chuck and the tailstock. The material is back in the lathe. And here we go. Press them in. I wish I could maintain that angle, but I have to see it from above. Sorry, guys. All right. That's a beautiful thing. Yes, it is. And just like the other one, I'm going to dust cut the inside face before I part it off, and we'll take a look at it on the bench. Okay, fresh off the machine, looking pretty good. Let's remove the tip, run it across the memory, take a better look. with minimal secondary. The back comes out real clean. I did roll up a piece of emery and pass it across the back side of the scallop where the scallop trailing edge meets the back face. You can see the slight break edge in there. Now, if somebody were to tell you could do this piece completely on the lathe, you'd probably laugh at them and walk away, right? Well, it just showed you that it is possible. And it's really convenient, too. The only thing is, I guess, rigging up the indexer. But that's you can do that with a bunch of Sharpie marks if you want. I decided to do it with a piece of paper. So this is the second one I made. Broached. Let's see if I can find the first one I made. Here we go. This is the first one. You can see the difference in integrity in the scallop area. See the lines in that one from the intermittent feed. And this one, the linear scrapes. I prefer the linear marks. I didn't do anything to these, actually. I did not polish those at all, just the trailing edge like I had said. Done basically identically the same way as far as pressing the stud in. It ran very concentric when it was done. No frustrating dies, no major trailing run out of the thread. There you go. Now this can be done, like I said, you give it to 10 guys, they're going to give it back to you 8 different ways. In V-blocks, hex blocks, rotary indexer, side mill, drill, plunge, ball nose, end mill, you name it. It's going to come out, well, like I said, you're going to get it back 8 different ways. And so long as it looks like the print, it's all good, right? So there you go. 2 pieces, 2 different ways. Similar results. I do appreciate you spending some of your day with me today. Thank you very much. Wherever you are in the world, I hope you're well, happy, and safe. All the above. Joe Pye, Advanced Innovations in Austin, Texas. I'm out.